Hello, and welcome back to Code and Cloud, the podcast where we explore the intersection of technology and strategy for modern digital projects. I'm Rauno, and today I'm proud to host DevOps, Cloud, Microservices, and the challenge of complexity. How to deal with the increasing level of complexity? What is the role of the architect in the context of distributed solution and distributed teams? Let's discover together the answer to those questions with our guest speaker. There is no need to introduce Luca Mezzalira, very well known for his contribution to the modern software architecture. A software architect with more than 20 years of experience, helping companies from startups to Fortune 500 building scalable and modern systems. Author of Building Micro-Frontends, Luca, today at AWS, guides enterprise in designing serverless event-driven architecture. Luca, thanks for accepting our invite and welcome to Code and Cloud.
Hi, everyone, and thank you for inviting me.
No, thanks to you. Thanks a lot for you. You want to just say a couple of words to present yourself to the audience? I mean, I'm sure many people know you already, but just for the few that don't know you.
No worries. So my name is Luca. I'm a serverless specialist solution architect in AWS. It's almost 5 years I'm working in AWS. Before I was VP of architecture at The Zone. That probably you have heard about it. I'm a published author. I worked on three books. Two with O'Reilly, that is the second edition, Building Micro-Frontends. I'm an international speaker with over 350 talks worldwide from Japan to Silicon Valley. And I have this passion of being part of the community and share as much as I can because I think, I'm fortunate enough to see a lot of things that many people might not have the possibility, and therefore I want to share whatever I'm seeing, whatever I'm experiencing also with others.
No, thanks. As you mentioned, you are really known for sharing insights with talks, open source podcasts that you organize and participate. But you also have an extensive experience building and running complex and innovative solutions, as the experience with The Zone was really innovative, what you were doing at the time and also after. In your career, you surely have experienced what we could call the paradox of the modern architecture. So we adopted cloud, microservices, DevOps, all with the promise of increasing the speed and simplify the development by breaking down the monoliths. But often we end up with new distributed complexity that can even be harder to manage than the old one that we all knew. From your perspective, what is the single biggest source of this new complexity and why so many teams underestimate it?
So I think the main challenge in distributed systems is that they promise a lot, however, it's not always possible to meet all the promises unless you invest into the idea of distributed systems. Majority of the time, companies starting very strong with distributed systems when they want to modernize their current system into something that provides more agility and better, outcomes and outputs and fruit for their teams. But the real challenge, though, comes to all the additional things that you need to think about when you're dealing with distributed system. Vast majority of the time, there is this idea, especially for companies that are starting, that are brand new with distributed system, that you can work in silos, you can have your team and you can do whatever you want inside there and off you go, you are good to go with distributed system. That's not the case. I think very often I highlight that we are not eliminating external dependencies, we are reducing external dependencies. That is a completely different approach, obviously. But more importantly, there are certain things that very often were organic in a monolithic system, like governance, that is, across all the teams. It was more centralized. There were less people that are taking decision. Now we are aiming towards, or we're shooting for, a decentralized version of that. And therefore, that means also that the way how you design your organization, the way how you design your system, the way how you adopt technology, take decision on design decisions are changing. And therefore, there are new, let's say, approaches that over times have shifted towards a more decentralized approach that I think started to be more concrete or holistically concrete when team topologies came in 2019, when we started to look into when team topology was embraced by the domain-driven design community and started to look more holistically of what are the parts that are affected when you take a decision around boundaries or around the technology, whatever. So I think there are some communities that really shine and move forward the idea of distributed systems that are not only technical. And I would say majority of the time, you don't even realize if there are, let's say, microservices or monolith, because as a user, you don't care if behind the scene there are a bazillion of APIs and services or just a single monolith that is serving everything. What you care about is the experience. But in order to achieve that, especially for considering now the raise of the high bar that the users we are used to, I don't know, buy a service or subscribe to a service or buy an item or good on website, requires to, let's say, have way more people, better experience, more multidisciplinary approaches inside the same system, and so on and so forth. So I think the economy and the environment is asking us to, let's say, collect a lot of knowledge in single systems, and it's not always easy to do. And distributed systems very often are overlooked on everything that is on as a second thought of distributed system that not related to technology, like governance, observability, stuff like that. Sometimes can be an afterthought, while I believe are integral part of the decision making and the success of a system.
Yeah, so you're raising a good point related also to the organizational aspect. You were mentioning unified experience or enhanced experience for the user. As a pioneer of the micro-frontends, you've seen the vision and the reality. The vision is one of fully independent end-to-end teams. The reality, if not well executed, can be performance bottlenecks and consistent user experience. That is one of the points you were mentioning before as how important the user experience and dependency conflict. How should an architect decide if the organizational benefit of the micro-frontends are worth the significant technical complexity that they can introduce?
I think, very often there is this concept of distributed system, triple equal, depends from the language that you're using, but triple equal to complexity. Complexity is something that we create. How micro is a microservice? How micro is a micro-frontend? So those questions doesn't have like a answer on the vocabulary. You cannot say, 100 lines of code means that is a microservice or a micro-frontends. You don't know that. The reality is more nuanced. And that's the part that I think people are often failing, going too granular very often into splitting up the system in tiny, small chunks without understanding the context. Because if Netflix has 1 million of microservices, why we shouldn't? The reality is different. I think there are a bunch of heuristics that we have learned over the years that applies to microservices as well for micro-frontends, that are boils down to rate of change in your code, it boils down on how big is your team. Because if you have like 5 people working on a project and you have like 20 microservices, I can tell you right now that there will be a lot of friction. That not necessarily is because microservices are bad. It's because you choose the wrong architecture for what you're trying to achieve. So there is these 3 elements that I usually take into account when I split up systems. The first one is, okay, how many people we have? What are their skills? Are we aiming to, let's say, grow massively in the next 6 months or not? Or we will remain always the same? Are we going to have any compelling things that is happening that will completely change and shift our scenario, our business in the next 6 months? Maybe the launch of a new service or product or whatever it is. And a bunch of, let's say, business and context-wise questions that are bubbling in my head every time that I start to look into a system. And then I started to split it up based also on rate of change if I'm possible. I remember in the zone, for instance, what I was trying to understand is first what was the full journey that the user was doing, and I identified like two main journeys. One was the journey for a new user that never heard about the zone and wants to understand more. The other one was for existing users. Those journeys are completely different. If I'm capable to optimize for those two journeys independently, then it's a big win. So we never went too granular on microservices or micro-frontends. We stay more coarse-grained because by far is easier is if you split up, let's say, a code base that is written by a single team, then aggregating two code bases written by two teams. The thing that I've seen more often than not is that when you have the second option where you want to aggregate services or micro-frontends, there is the tendency to, let's say, trash immediately the code written by the other team and rewrite from scratch because it suits better the system. But that is a disservice for the company at the same time. Now, I think it's important that to understand a few heuristics that I usually use for splitting up the system. So first of all, I look into domain-driven design. I look on identifying the boundaries of the system. There are techniques like event storming, for instance, or domain storytelling, where basically you are going to look into how your system works from a business perspective, not a technological perspective. You start to identify the boundaries, and when you have that, you can test the boundaries. You can start to say, okay, so let's see how much communication we have between these two, how it's working, and what if we split in this way? How we are going to handle this stuff, or if we identify two, let's say, two boundaries that have, let's say, they're not high rate of change. There is obviously an investment at the beginning to build them, but then it's keep the lights on till the rest of the life cycle of an application. I can even decide to bundle them together because the changes will be minimal on that side. And then, you start to, when you identify the boundary, you start to categorize them. Say, okay, so this one is core for a system. This is not core. For instance, in the case of the zone, the core part was the video player, the catalog, and stuff like that. But the part that wasn't core is you need to pay in order to subscribe, but there is no key differentiator there. Therefore, I can use SDK, I can use external SaaS products or whatever. So now you start to understand that you apply characteristics to subdomains thanks to domain-driven design, and then you start to design things, let's say, holistically about that. And Micro-Frontends was the same. So when I look into this, I started to define these boundaries, optimize it for the two, let's say, journey that I identified, and then start to collocate things. For instance, the catalog, the video play, the catalog was one Micro-Frontend that contained the details, the personalization part, and so on and so forth. But the video player was something that we need to change very often in order to optimize the heuristics and everything. Therefore, was an external element that we load at runtime every time. On the other side, we had, for instance, the onboarding experience that is usually, I don't know, the sign-in, sign-up experience. That at the beginning was a single Micro-Frontend called the onboarding Micro-Frontends that had the sign-in, retrieve email, retrieve password, sign up, and payments all together. Then they started becoming unmanageable very quickly. So the problem was around the payments. And when we were looking into the payment side, the proposal was, okay, let's carve out payments and we make a Micro-Frontends. But logically speaking, didn't make any sense. Because payment was used only in the sign-up journey, not in the sign-in journey. And splitting up these two, logically speaking, didn't make any sense. So the user either is maybe bought a new MacBook and wants to sign in inside your system, or they want to sign up. These is the real split. So the sign-up part will contain the payment that is tightly coupled. You cannot have sign-up without payment. Therefore, that is an aggregation part or an integrator, as I call it. And then that is a unique domain that is owned by a single team. Then we have another one for sign-in that is by far simpler. So you have just sign in with retrieve email, retrieve password, but that is a different kind of user. So it's an existing user wants to sign in a new device or an existing device. So this logic enables us to not go too, let's say, vertical on splitting up everything and having the micro-frontends for payment, the micro-frontends for the form, micro-frontends for this, micro-frontends for that. And then also there is a combination of pragmatic decisions that sometimes you need to take. Like, for instance, I know that governance can be painful, especially for stuff that doesn't change very often. And therefore, instead of thinking about governance, what is the other way that you can leverage in a situation in distributed system? Could be duplication. Why do we need always to start with abstractions? That was a question that I raised 10 years ago to myself. And very often as a developer, I'm guilty of that. I love creating abstraction, creating libraries, creating things that could be shared because it's cool. It's absolutely a nice engineering problem, and I love that a lot. But the problem is it's not practical, because it's not a problem writing the code, it's maintaining the code the problem. How can I update this library that now is distributed across multiple systems? Now, there are tools nowadays compared to 10 years ago that can solve this problem very nicely, like Dependabot or other things. But the reality is, people don't think on the consequences of just creating yet another shared library. A shared library in distributed system is a challenge, a real challenge. No matter it's micro-frontends or microservices, it's a problem. If I change the log library in a microservices environment and they have 200 microservices, but then I need to stagger the implementation. I need to create like an iterative approach for getting there and making sure that all the microservices have the same thing. If I change an API in microservices and I want to deprecate a field, I cannot deprecate straight away because you don't know the cascade effect that you could have inside the system. There are a lot of considerations that you need to take into account when you look into distributed system and therefore also micro-frontends. And I think that the one thing I want to demystify is the myth that micro-frontends has a hit on performance. Quite the opposite, actually. We use micro-frontends and they were designed in that way, even before they were called micro-frontends, for low-end devices. Because what we realized very quickly is that if you target like, I don't know, devices like set-top boxes or something like Fire TV stick or Chromecast, stuff like that, you know up front that the power of those devices is really poor. And therefore, what you need to do is reducing the amount of memory allocated for useless code. And if I know that the user is subscribed, then I don't need to load the payment methods. Then I don't need to load the logic of sign in, sign up. Then I don't need to load the landing page, and so on and so forth. So you see where I'm getting. So now my application for an existing user is the video player and the catalog, period. That's the only thing that they load. The beauty of this approach is that also vice versa is true. If it's the first time that I'm logging on the application, I load the micro-frontends for the landing page that explain the logic of what is available in the zone and the price. If you want to go ahead, you can go ahead. If you want to load, you are an existing user, so you want to sign in, you go on that side. But the beauty of this approach is that if you do a proper analysis at the beginning, you load just enough code to make it work. The problem very often I've seen micro-frontends implementation failing is because we think the micro-frontends are equal to components that are completely different things. Because the reality is components, the main reason why we create a component is abstractions. So we want to reduce duplication. Micro-frontends, the aim is accelerating the deployment, reaching the fast flow, and having independent teams. So as you can see, the idea are completely different. So you cannot have components loaded at runtime and then blaming the architecture. 90% of the time when I hear architecture complainings, it's because either people don't understand the context or they didn't understand what characteristics they need to express inside their context. And these are usually the challenge that you face in distributed system, because it's not anymore. And let's say I choose a framework, I follow the framework, and I put everything in a box done. There are a lot of consideration that you need to take into account. Resilience, reliability, SLAs, I don't know, any other, let's say, rule that you need to apply into a system. And there aren't right or wrong, because we are working in an empirical system. Empirical systems are not scientific. In order to discover something in an empirical way, you start with trial and errors. So you need to accept that. You need to accept that you need to work iteratively. There are frameworks that helps you to do that. Like if you think about Scrum, it's just providing an idea of how you can tackle a problem for a short amount of time and iterate on that and make it better the next sprint, the next sprint, the next sprint. It's not something that goes against development. It's just providing a guided or guardrails on how apply an iterative approach. Very often, I heard developers blaming Scrum because, but it's pointless or whatever. I can tell you, if you apply properly Scrum, and when I was lead engineer, for instance, I used Scrum in order to solve a problem that was the last 2-3 days of merging code, rushing to merging code for the end of the sprint that everyone hated. Because you work for basically in a 2-week sprint for 7 days, working days, you work on code, and the last 2 days you work on fixing issues. That is super annoying. While what for me was the reason because we will reach that point is because we kept the branches out from main for too long. And when you look into that, I mean, it's okay. Why is happening? Because we don't spend enough time on stories. We don't spend enough time on defining the tasks. So let's try to fix that. Let's try to apply tasks that are no bigger than half a day. The first sprint you struggle. The second sprint is slightly better. From the third sprint onwards, my team was the most successful one of the whole studios. We were 100 people. There were like I think it was roughly 10 or 11 team studios, how we call them, and the reason being is because our policy was half a day open branch. At the end of the sprint, we didn't have anything to, let's say, fix or whatever. It was exactly what we planned because we spent more time on the planning phase. We understand what we want to, we were thinking more thoroughly about what we need to express into the system. And that's, for me, is the juicy part of also distributed system. So this idea that you need to invest time, it's not that you will just write code and it will work. It doesn't work in that way. Sorry for the long answer, but...
No, that was, I didn't want to interrupt you because it was really interesting what you were saying. So not only technology and architecture, but also related to organization and to planning and anticipation of the solution, and lots of attention to the user journey, to the business aspect of the solution. And you mentioned governance and the decision to be taken and the role of the architect. And considering this in this work that you described of the distributed system and autonomous teams, what is the primary role of a modern architect? I mean, is this role shifted from being the master builder that designed the blueprint to be more something like as a digital city planner, set the zoning laws, manage the overall infrastructure, and helps the team to navigate the landscape, but not maybe providing a more directive governance and strict into the technical details? How do you see? I mean, you shifted from a developer to a lead developer, team leader, to a full architect, solution architect role in big environment with multiple teams. So how have you seen this role evolving?
I think the architecture role evolved a lot in the last, I would say, 10 years. I don't see anymore. So I think it depends from the industry, right? So more regulated industries we are still anchored on having the enterprise architect, the group of senior principal, the staff, and so on, working together as an architecture team, defining the rules, stuff like that. But then the friction arises when basically there is to land these rules plus blueprints into the field, and the field start to implement the things more or less following everything. I think there is a request from the companies, more modern companies, if you want, or startups, to delegate more towards the edges of the hierarchy, therefore developers, teams, etc. I think the role of an architect is becoming what in team topology is called an enablement team, where you start to look into, okay, we need to own certain characteristics. We need to understand the business requirements. We need to remember, or better, help to remember the developers what we are shooting for. But it's inevitable, in my opinion, that at some point there are certain decisions that definitely can be handled to developers. Absolutely. So I think they are in the perfect position for taking certain decisions. The challenge I see is when you start to look into cross-country concern. So if I have a feature that span across multiple boundaries, my fear often is that the stronger personality will impose the direction of travel, while we need someone that is more impartial, if you want. Now, we started to see some interesting mechanisms around how to democratize this approach where people can take decision, but there are also some reviews by peers review and architecture teams review. There is a very interesting book that is from Andrew Harmer Lowe, that basically talks about this decentralization or the practice of scaling the architecture through teams, where the idea behind that is quite interesting, is the fact that he wrote an article on Martin Fowler's blog back in the days, and he basically described this idea where the architecture team shouldn't design everything, should instead have the developers or the teams that wants to propose something, that will make a decision, and then we need to review with the architecture team, acts like an enablement team, and the consumer of that API or whatever it is. If you have these two checks, you will be able and entitled to start the work. And if you see also in the past, when we started to do architectural decision record or request for comments, stuff like that, there is this idea where I fleshed out the specific idea that I have, a new implementation, a new feature that we want to implement, or maybe an improvement on an existing one. And then there is this socialization, asynchronous socialization, where people can contribute through RFC in terms of comments, ADR in terms of maybe meetings or whatever it is. And I think this part is very interesting, because when you look into that, you start to see now how it fits very well in the distributed system fashion, where if I have the possibility to write the code, I need to have skin on the game also to take this, say, architectural decision inside my domain, that for sure. But also have a skin in the game when we are introducing new things. Very often, the problem is that developers nowadays, if you think about the variety of things that they need to do, they're extremely stretched. It wasn't like that back in my time. You write the code, you test it, you hand over the code to the DevOps team or whatever you want to call it, and till is in production and someone screams for a bug, you are fine. Nowadays, the developers team needs to know about architecture, security, observability, DevOps, infrastructure, coding. It's a lot. Okay, so I believe that distributed system enables you to reduce the cognitive load and also focus on a multidisciplinary approach like developers has. But it's inevitable that some developers or some teams have some strengths and some weakness, right? So I think the role of the enablement team and the role of, for instance, I'm thinking also the security team is another enablement team for me, should be creating mechanisms inside the company for scaling their needs. Very often in the security team or in the architecture teams, you design things that are beneficial for the entirety of the system. They might affect maybe a portion of it, but it's helpful for several things. I remember back in the days in the zone, we need to figure out a way to test our system end-to-end in every country. So we need to find a way to do that. And we created what we call Marco Polo, because it was a way to travel the world through basically a sort of feature flags. It's documented in the Zone blog if you want to read about that. It's very interesting. But the idea basically was we pass an ID that enables you to trick the the system in order to say, okay, I'm currently acting like I'm in Vietnam instead of UK or Italy, wherever it is, right? And that enabled us to test things differently. That is something that you can potentially think, okay, I will hand over to the developers, but the whole process what we were trying to solve is launching 200 countries couldn't be done with the normal ways that we were doing before, because we were launching country by country. Now we are launching 200 countries. How do we do that? And it's a problem that the QA came up with, and we need to figure out a way to do this. And I think there is still a lot of value on an architecture team, probably smaller, but I think the mindset needs to change in a role of, I cannot say only, but more, let's say, focus on coaching people, because it's inevitable that usually if you're an architect, you have seen, let's say, a bunch of things that maybe developers don't. And being there with your experience, you need to be capable to help and democratize this experience, if you want, to all the developers. I organized like office hours back in the days. I organized, there was a town hall, there were a community of practice. We pair with the security team in order to do let's say security review on our system, and we pair with the platform engineering team, with the developer experience team. So I think that the role is not anymore, I just draw lines and I design a system. That definitely, especially at the beginning, maybe for a modernization or migration, can help. But I think it will be more than that later on. And definitely, even when we were designing stuff back in the days, we weren't, let's say, just providing a design that is the design period. It was still socialized. We were just accelerating the design process, but we were more than happy, my team, to embrace also the information that the developers has. When we started to be, let's say, quite large, over 500 people in the tech department, there were certain teams that they were very good. They were good developers with a lot of experience, stuff like that. So they could take their own decision. And also, if you think about that, certain teams they don't have the same importance or critical path or other things that we were caring about. Therefore, I think this role of an architect is changing to a certain extent, to become a force multiplier inside the trenches, and enabling teams to take the right decision with the right mindset. I think architects with experience are really, really good asking the right questions and trying to find the trade-off. Too often, developers tend to go with best practices, but what is a best practice? If you don't understand the context, a best practice for Netflix could be using a distributed system. A best practice for a startup with 2 people probably is going with a monolith. So who is right? Both. But it's the context that drives this decision, right? So I think developers often goes in that trap, and I'm guilty on that as well when I was a developer, because you are used to think, okay, so these 3 lines of code are better optimized or perform better than these other that I've written. So I'm going with the absolute. This is the way to go. But architecture is way more nuanced. Things that might be anti-pattern for others might be totally suitable for your context.
Yeah, context is the king, as
always.
We used to say always. You mentioned already one point that I wanted to get your view on, cognitive load. I mean, we're talking about delegating certain level of decision to the team. I mean, it's something that matches what is one of the core principles of DevOps, empowering small autonomous team. But with the complexity that we were mentioning before, there can be some cognitive load on the developer. I mean, you already mentioned in your previous answers some of the role of the architect on trying to facilitate the life of the developer, to reduce their cognitive load, to be as a coach or a guidance into that. But are there any patterns or tool or way of dealing with the different teams that an architect should consider in order to try to reduce the cognitive load to the different teams of developer?
Totally. As architecture team, I think identifying patterns that could work in your context without, let's say, reinventing the wheel every time is helpful. So if you know that you have like, I don't know, a REST API, let's say, implementation for your microservices, you don't need to say, okay, create an API gateway for each single microservice. Maybe at the beginning, if you want to have throughput on the teams, then reduce the external dependencies. But then at some point, you reach a point where you have an entry point that is unique for your APIs. And even if you go with the first approach, so the former approach where you have an API per gateway per team, you can commoditize to a certain extent. So you can say, okay, this is the way how it's going. This is the infrastructure as code that I produce. It's already with all the bells and whistles. We know already the integration with, I don't know, the IDP, the identity provider, or we do already in communication through passing JWKs between system to system. So you have some blueprints that the developers can take, tweak up to a certain extent, and then start to hit the ground. That is basically, if you want, is the collaboration of platform engineering I was mentioning before. There are certain things, for instance, I remember in the zone, we decided to switch from JWT token communication to HMAC. And therefore, the platform engineering team created the HMAC server for handling the communication, validating the different tokens and so on. And with the help of the security team and the platform engineering team, we generated basically a template or the blueprint that then was used to clone in every single microservice. Those kind of activities, I think, are a way to reduce the cognitive load. When you see that there are several teams that need to implement something common, that is where you should step up and collaborate with different other teams in order to identify what are these things. But it's not only on the technical side, it's also on the behavioral side. I remember a brilliant things that the security team did back in the days in the zone is the idea of security champions. So we had like several teams. We were talking about 550 people when I was there at some point in the zone. And we had like 4 dev centers. Security team were, I don't know, 4 or 5 people, something like that. You can understand the ratio is very complicated. Therefore, the idea of security champions was very simple. So they selected a bunch of people. So it's usually a ratio of 1 every 2 or 3 teams in each single dev center. And they were able to train these people to a higher level with the foundational part of security we needed to implement. And they became the reference for the teams that we're working with. The beauty of this approach is that when they need to update these things, they don't have to create a mechanism for, let's say, broadcast to everyone everything. They did the announcement. Then they leverage basically the security champions in order to, let's say, make sure that the implementation, documentation, stuff like that is used. And I see also in AWS is similar. In order to scale for the amount of people that we have in AWS, you need to create mechanisms. For instance, I'm working on the specialist side, and the specialist side, we are not, let's say, millions and in each region. So and therefore you need to find a way where you can scale. So there are mechanisms called the technical field community that enables you to basically explore more in depth the specific area of the service that you're interested on, machine learning, AI, serverless, whatever. And then you will be responsible to help the others that maybe are becoming more expert in another area that you are not expert. And with these things, we are capable to basically, as a specialist, we take the most challenging parts, while the field community is taking care about the less challenging, more common things. And then we decide even if we see that there are patterns or requests, like, I don't know, there are 10 requests that are asking us if a Lambda function should be a monolith or should be multiple single purpose or wherever. So then we gather together a group and we start to say, okay, so probably it's reasonable if we create a best practice around that. So every time that someone is asking, we have a link that that we can send to a code example, article, white paper, whatever. So this kind of mechanism I've seen in organizations that start to scale, it becomes a way for the democratized knowledge that I think is also where I see the architectural practice in the future.
That's interesting. Your experience is not something common to everyone. I mean, you've been in very innovative, but also very big teams with a global presence. And you have been working with the Zone first, with AWS, now in cloud environments, worldwide extension. Cloud landscape, as we see, is something that changes constantly. So what is a best practice pattern today can become a technical debt tomorrow. So when you're designing a system, how do you balance the need to solve today's problem with an elegant solution against the need to make architectural choices that will make it flexible, reversible enough also, in order to adapt it to the future, a future that you can't predict because you maybe can have some insight because of your position now, but you don't know exactly what will be the new services, the new technology, the new pattern that will raise in the next month or year. So how do you, as an architect, deal with that?
So let's start with saying there are no bulletproof solution for making sure that what you design today is not going to blow up in your face in 12 months or with the rate of AI now, or or in 24 months, whatever it is. Therefore, the only thing you need to accept is changes. I think as an architect, usually I try to get a good grasp of the context. You know, I'm talking with a lot of customers worldwide, and first and foremost, I need to understand, okay, before we talk about anything that is technical, let's talk about how you're structured, what kind of things you are expressing. And you would be surprised on how many large organizations, when I'm asking, for instance, okay, are you bounded to specific latency? The answer is often yes. And what is this latency? Is zero. So zero latencies can be reached, obviously, in monolith. So you cannot do in the moment that you go to the network, there is latency associated to it. So it's period. There is other way, unless we challenge the physics, but I don't think we're going to. Therefore, I believe that is important that you design architecture with a lean mindset. So it's impossible to spend months gathering everything. That is something I don't believe it will change drastically the way how you are designing things. You need to gather enough information that will enable you to have a good design. Now, as I was mentioning before, how micro is a microservice or a micro-frontend, the thing that you need to ask yourself and trying to find information on is rate of change of specific areas, and also how the teams are structured. Very often, you know, I've seen teams complaining because they are dealing with, I don't know, 3, 4, 5 microservices or micro-frontends when no one told them to do that granular. I mean, if you are living in a domain and you are communicating inside there, even if you are not following perfectly the best practices in the world, it's your own code. You can change without affecting anyone if you did a good job, providing, let's say, good value. Therefore, I'm more interested about looking holistically on how harmoniously the communication flows inside the system and therefore inside an organization. While if you are inside the domain, and I know that domain is owned by a single team, that is just an engineering exercise. Then yes, we can express certain things, and I'm helping teams on doing that. But if I need to change something there, I know that will take probably a sprint or two. While if I need to change something fundamental that could rely on multiple teams affected, I will play more careful. So I will spend more time understanding these things. So that is usually one thing that I do. However, you know, I very often what I also try to surface at the beginning is certain important information that are not fully taken in consideration, in my opinion, often. That is, okay, so how resilient should be your system? what is the uptime that you are looking for? If this area of the system is down for 24 hours, is a problem. If we lose data, is a problem, because those things that seems very often are taken afterwards. So I implement the features, I don't ask these questions, and then suddenly, oh, by the way, I need to tell you that your system has to be active in 3 regions and take the traffic and reduce the latency. So it's completely changed the way how you design things. And also often I challenge products. And what I mean by that is that product obviously has this vision that their experience should be amazing in this new feature that is coming. But I think you need to put things in context. An example is when, for instance, we were looking into the implementation of gift cards in the zone, we made, let's say, synchronous the validation of a gift card, but completely asynchronous with let's say a very let's say a slow SLA of minutes, if not hours sometimes, for synchronizing third-party companies that were providing us gift cards. Because for them, if the user is right now consuming a gift card, doesn't change anything. They just need, at the end of the day, to know that these 105 gift cards were consumed from them. That's what they need to know. So the way how and at the beginning, obviously the features or the product says, okay, we need to notify these things, and you start to ask questions. But very often when you start to dig deeper in the requirements, you discover that certain things can be handled asynchronously very nicely. And that means you can reduce the cost because you can work in batches instead of having every single event there. You can have a super fast reply towards the client or the consumer. And then you start to design things in a way that is optimized. And despite there is a bit of delay, no one will, let's say, die or will have, let's say, a bad experience. Even with customer support, sometimes there was a tiny delay of a minute on synchronizing certain things, but that enables us to, let's say, have a lower cost, less reducing the strain towards all our services. Because especially when you have like a burst traffic like we had in the zone, you don't want to have a cascade effect across all the different services, because otherwise, when you design a system for 1 million requests per second or 500 requests per second is a completely different ballpark. The way how you design things is different. So now if you have a cascade effect, you say 1 million second here, 1 million here, 1 million here, the system to test, to manage, it's extremely complex and a very expensive. While if you take the hit at the beginning and try to minimize the interaction with other system, and then you batch everything later on, then it becomes very interesting because you can apply more elegant solutions, and also you can create buffers, you can work with batches and reduce the strains towards the rest of the system. And we know nowadays that you cannot build everything. I don't know many companies that are building an internal CRM or an internal CMS. Now you take a SaaS product, right? And even when you interact with them, in this case, obviously, it's a multi-tenant approach. Therefore, you have a limit on how many API you call to them. And therefore, in this case, you need also to think, okay, perfect. So if I have that, I need to create some buffer. So even if you handle 1 million requests per second, on the other side, they won't. And therefore, you, in any way, you need to create buffer, you need to create the resilience. So that you create there or you create at the beginning, it's not a big deal. So there are a lot of reasoning around these things that I think is important to think about when you're designing your distributed system. But for me, probably the main takeaway here is ask questions. Ask a lot of questions, and not only take for granted, because the product team said that. Product team has his own idea, obviously, but at the end of the day, building a solution real-time and near real-time and in batches have completely different implication, design and cost. And therefore, you need to be aware and make aware people that these are information that needs to be surfaced. So let's try to discuss that and trying to have, let's say, a pragmatic approach. Because yes, everyone would like to do analysis real-time, But in order to put that, especially if you have a large system, it's extremely expensive and onerous and complicated to maintain, because it's not building, it's maintaining the real problem. So we need to figure out ways that we need to be more pragmatic. And the only way is surfacing the problem through questions, not challenging in a harsh way your colleagues, but asking the question, like a genuine question, like, okay, so if we do this, this could happen. How do you feel? If we are down for X amount of hours, how do you feel? If we lose this data, how do you feel? So these kind of questions that seems, let's say, not relevant are the ones that make your life better as a developer, as an architect, and the system more resilient.
Okay, no, that was a point that was covering many aspects. So I'll try. I mean, it has been a very intense conversation. It's really a pleasure to listen to you. Let's try to wrap up. So I took just some points that I will mention to you that were some keywords that I structured for your conversation, and then I will leave you if you have just one sentence to try to wrap up it all. So the keyword I kept, I took note where you were discussing, get the context. Not all solution and not all modules in the same solution have the same non-functional requirements. Understand the rate of changes. Question how micro is a microservice or a Microsoft front-end. The importance of the team topology and the organizational structure. To have an empirically interactive approach. Architect as a coach or a guide. And finally, I really liked it a lot with your last answer, architect role as the person whose role is to ask the questions. So am I right to getting all these keywords, and how you would wrap up all this conversation in 1-2 sentences for our audience?
Yes, the keywords are absolutely correct. There are way more potentially, but I think one takeaway, there are 2 takeaways probably I would like to share here. I think it would be interesting to hear if they land. So the first one is, when you're designing a system, don't think statically. Remember that the system will grow, and means changing, evolving, removing parts, adding new parts. So you need to treat that not as building a system, but growing a system, like is organic, because that is what the system are nowadays. And the second one is that don't look only on the technical side. There are 3 dimensions that you need that are interconnected, that you like it or not, that are engineering culture, organization structure, and architecture. The moment that you take the simple decision, like I want to go a monorepo or polyrepo, you are affecting those 3, no matter what. Because the way how you request people to have their engineering principles and approaches is completely different from monorepo and polyrepo. Similarly, when you decide to go with microservices over monolith or modular monolith, you are affecting the way how people should think about that stuff. So the way how you structure the team will be different, the way how you do governance will be different, and so on and so forth. So always think that there are 3 forces that wherever the massive decision you made in a system will be affected, directly or indirectly. Your goal is trying to minimize the chaos inside the organization, and therefore taking into account these 3 dimensions to reach essential complexity.
So architect is not only a technical, it's really more holistic vision inside the company, its business, its structure, and this is what needs to be taken into consideration, taking all the decisions. So thanks a lot, Luca, for all the really precious insight you gave us today. Thanks a lot for having been with us for this session.
Thank you, guys. I really appreciate being here. And yeah, I hope that was helpful for the people that were listening to us.
I'm sure it was. Definitely it was for me. It was really helpful. So thanks to Luca again. Thanks for everyone listening to CODE&CLOUD. The conversation doesn't stop here. So please join us in our social account to share your thoughts on today's topic. And if you enjoyed the show, please subscribe, leave us a review. It will really help us on helping other people to find us, but also helping us to understand if we are going into the right direction, which are the subject you are interested into. So be sure to follow us so you don't miss our next episode, where we'll be talking about intelligent convergence between new balance between edge and cloud with Luca Mezzalira, Senior Solution Engineer at Akamai. And until the next time, keep your code clean and your cloud scalable. And as we used to say at Newesis, be professional and have fun. See you next time.